Hi, welcome back to the channel. Understanding which crankshaft sensor is installed in your vehicle is crucial for proper diagnosis, maintenance, and replacement. A crankshaft sensor plays a pivotal role in monitoring the position and rotational speed, or RPM, of the crankshaft, information that the engine control unit, or ECU, uses to regulate ignition timing, fuel injection, and various engine parameters. Crankshaft sensors are essential components in modern engine management systems. Their primary purpose is to monitor the position and speed of the crankshaft by detecting changes in magnetic fields or optical signals. The sensor sends a signal to the ECU, which then synchronizes fuel injection and ignition timing based on the exact position of the crankshaft. If the sensor fails or malfunctions, it can lead to symptoms such as engine stalling, misfires, or complete failure to start, making correct identification critical for troubleshooting and repairs. There are several types of crankshaft sensors, and each type works on a slightly different principle. Inductive or variable reluctance sensors. These are perhaps the most common and cost-effective type. Inductive sensors generate their own voltage when a ferrous tone wheel or reluctor ring attached to the crankshaft passes by the sensor. The voltage generated is proportional to the speed at which the crankshaft rotates. Since these sensors are passive, they do not require an external power source. Their simplicity makes them robust in high-temperature environments, although they might be less accurate at very low speeds. Hall effect sensors operate on the principle of the Hall effect, where a magnetic field induces a voltage in a semiconductor material. Unlike inductive sensors, Hall effect sensors require an external power supply and typically have three terminals: power, ground, and signal. They tend to produce a square wave output, making them more suitable for precise timing requirements. However, caution is needed when testing these sensors because applying an ohmmeter incorrectly can damage the internal circuitry. Optical sensors and magnetoresistive sensors. Although less common in everyday automotive applications, optical sensors use light to detect the passage of a marker on a crankshaft, while magnetoresistive sensors rely on changes in resistance in response to a magnetic field. These types are more specialized and can offer improved precision under certain conditions. Determining which type of sensor you have installed involves both a visual inspection and consultation of technical documentation. Here are several steps to help you identify your sensor. The service manual for your vehicle is the primary source of information. It will detail the sensor type used for your particular engine and provide part numbers, wiring diagrams, and specifications. OEM parts catalogs often include detailed illustrations of the sensor, its connector type, and mounting configuration. A quick visual inspection can provide significant clues. Many inductive sensors come with a 2-pin connector, although some models may use a 3-pin setup that includes a shield wire. In contrast, Hall effect sensors typically have 3 pins: power, ground, and signal, because they require an external voltage supply. However, note that some inductive sensors might also appear with 3 pins if additional shielding is provided. Some manufacturers design proprietary connectors. Comparing the connector against images or diagrams in your vehicle's manual or an online parts database can confirm the sensor type. Crankshaft sensors are usually mounted near the flywheel, crank pulley, or on the engine block where they can see a tone ring or reluctor wheel. The sensor's size and shape may differ. Hall effect sensors are often more compact with integrated circuitry, whereas inductive sensors might be bulkier and have a simpler construction. Once you have a hypothesis regarding the sensor type, you can conduct electrical tests. For an inductive sensor, disconnect the sensor and use a multimeter set to ohms to measure the internal resistance. Typical resistance values range from a few hundred to around 1,000 ohms. However, resistance tests should not be performed on a Hall effect sensor because applying a resistance measurement may inadvertently damage the sensor's internal circuitry. With a digital multimeter, or preferably an oscilloscope, You can monitor the sensor's output while manually rotating the engine using a wrench at the crankshaft pulley bolt. An inductive sensor should produce a sinusoidal waveform, while a Hall effect sensor will typically produce a square wave signal. Note that if the engine is running at high speed, most multimeters will average the voltage. Using an oscilloscope can provide a clearer picture of the pulse characteristics. Online communities such as automotive training forums or dedicated car enthusiast sites can be an excellent resource. Experienced mechanics and technicians often share their methods for sensor identification and troubleshooting. These practical insights can complement the information provided in official documentation and service manuals. Correctly identifying your crankshaft sensor is not only about knowing which sensor you have, but also ensuring that any diagnostic tests or replacement procedures are performed accurately. Using the correct testing method is critical. Using an ohmmeter on a Hall effect sensor, for instance, might destroy the sensor if done improperly. Always adhere to the manufacturer's guidelines, and when in doubt, consult a professional technician. In conclusion, understanding what crankshaft sensor you have involves consulting technical documentation, performing careful visual inspections, and conducting the appropriate electrical tests. By following these steps, you can determine whether your sensor is an inductive type, a Hall effect type, or another variant, thus enabling you to troubleshoot issues, replace the sensor correctly, and maintain your vehicle's performance reliably. This comprehensive approach ensures that you not only identify the sensor type, but also appreciate the sensor's role in the overall engine management system, a critical aspect of modern automotive technology. If you like this video, give it a thumbs up, share, and subscribe to this channel for more informative videos.